function. It's the only function that does that. All other functions, when you do the difference quotient on them, it turns into something different, something new. This one doesn't get changed. It is itself. It comes back to itself. A way I can make you see that visually is that when you have this exponential function, the difference quotient has to do with finding the slope of a line that's tangent. That's what the difference quotient gave you. It gave you the pitch of this line. It turns out that with this function and this function only, the pitch of this line is exactly equal to the y coordinate. So watch. What was e squared? 7.389. Here's what I can tell you. If you graph the exponential function and you go out to 2 and you go up and you try and find the slope of that line, the slope of the line is going to be 7.389. If you go out to 1 and you plug in and you try and find the slope of that line, guess what it is? 2.718. If you go out to 3 and you go up here and you're trying to find the slope of that line, guess what it is? 20.08. It is, the slope of this line is exactly equal to the function's value there. The only function that exists that does that. No other function does it. So we say that this function is its own derivative, which is what makes it so special. So you'll do a lot of work with that in Cal 1. All right? For us here in college algebra, we just want to be familiar with it. We need to be introduced to it. Here it is, e to the x. Got it? No. That's energy. Yep. Different symbol. Yep. And on your calculator, do any of you see a key that says EE? Okay, that's not it. That is basically like the E. When we got that answer, 9.22 E18, that key is that key. It allows for scientific notation. So, all right. All right. Let's see here. I'm just trying to move through this section, make sure I'm getting all the bases covered here. Let's do some transformation graphing. Man, this class is dragging today, isn't it? Slow. Seems like we've done a lot and still have a long way to go. Sketching with transformations. I would ask that you go back and review if what I do right now like throws you off. It was 3.4 and 3.5. 3.4 and 3.5 is when we did toolbox functions, library functions, and then we did the transformations. I'm just going to pick up right where we left off there and just start doing some transformations and sketching for these exponentials. So as an example, to start, I want us to sketch f of x equals 3 raised to the x minus 2 minus 4. I want us to find the domain and the range. Any ideas?
Well, we're going to go down 4 because the minus 4 is the negative.
Okay, we're going to go down 4. I agree.
So we know that the 0, instead of being 0, 1, it's going to be 0, -4 minus 3.
I agree with the down 4, right 2. Where's the right 2 coming from? -2 right here. So you got to go back and review this. These numbers somehow told you left, right, up, down. But remember I told you that the order was important? That you got to work with like an order of operations or else you can actually get things messed up? Our order of operations here, we're going to start right in here first. If you plugged in an x, this would be the first thing happening, right? So you're going to have to do -2 moves the whole picture to the right 2, doesn't it? Opposite of what you think. And then other than that, down 4. But what is it moving to the right 2 and down 4?
What would be at least 0 horizontal.
Like what's your toolbox function here? What's the thing that's being moved around? What exponential?
The function.
3 to the x. 3 raised to the x. Okay, so what we have here is our toolbox function is actually 3 to the x. And then what we've done is we've subtracted 2, which moved it to the right 2, and then subtracted 4 here and moved it down 4. Understand that? So we have to know what that looks like first before we start moving it around. So let me draw a kind of detailed picture of this. I know for sure, and I'm drawing the toolbox function right now. I'm not drawing my final answer. So I'll keep it in blue. I know that that goes through 0, 1. At 1, where would I be? 3, 2, 3. At 2, where would I be? Careful. 9, right? Way up here at 9. We knew it was exponential growth. Goes like this. That's the toolbox function. Now let's take it, let's move it to the right 2 and down 4. So right 2, every point goes to the right 2 and down 4. So how about we take this point right here, move it to the right 2, down 4, right there. Agreed? This one right here to the right 2, down 4. Right there. What about this one? Right 2 and down 4. If I move it down 4, it'll be somewhere around here, like at 5. One more piece of the picture I need to draw on here. What have I not really included here? The horizontal. So tell me what happens to the horizontal.
If it's 0, it goes down 4.
It goes down 4. Moving it to the right 2 doesn't change the fact that it's still a horizontal asymptote, right? So what I am going to move it to the right 2, though. I'm going to go like, okay, there's 2, and I'm going to move it down. So when I move it down 4, I should be, here's -3. Here's -4. So to the right 2, down 4, it's going to be somewhere around there. And then I'm going to draw my picture. Whoa, shit. Turn. There you go. Good enough. Good enough.
You said sketch, not plot.
Yeah. It doesn't have to be perfect. When you see sketch, it's just get us a rough idea. Yeah, it's just like we don't know how high they go or low. Same sort of thing here. What about the domain of this red one? Is it still all real numbers?
All real numbers.
Yeah, because you can still plug, for every x, there's some y that comes out. So domain is still all real numbers. The range is different, right? -4 to infinity. Not including -4.
And then the HA is -4.
Yeah, we kind of know that from here, but yeah, if you wanted to put it, you could. I didn't ask for it, but the HA would be y is -4.
Really, you asked?
Usually not.
Ask for it in some of the
Because you kind of have to know it. What's that? It does?
Yeah, homework's asked for some of the questions it does.
Yeah.
Okay, well, yeah.
All those kind of implied when you have to figure it out.
Yeah, see, these are the things you got to be paying attention to, I guess, as you move on and take more math class. Hopefully this is happening with you here, is that, I'm not going to show you every single thing. Some things you have to actually pull out of whether or not you understand it. If the homework asks you to do something, I didn't ask you to do that, but do you understand what's going on? If you do, then you can interpret it and do it. It's called becoming an independent learner. I'm trying to explain this to a 13-year-old recently. Trying to...
Dad, you told me to be independent. Well, not that independent.
To be good at of not needing someone to hold you by the hand and show you, like, that's one of the big things I see in math students is that, just show me an example so I can basically mimic what you're doing. And that's not what math is. Math is about you understanding conceptually what's happening. Of course, you need to see someone do a bunch of things, yes. But at some point, you have to absorb those ideas and be able to do a problem that you haven't seen and be able to kind of like, I know what I'm doing here. Does that make sense? Monkey see, monkey do won't turn you into an engineer for sure. All right, we're still good here.
Well, I guess we can't do the broken bridge over everything.
That's right. Not everybody gets to get a bus off the edge of a cliff. Only a few, select few, will be able to do that.
Hey, when I do it, it'll be in style.
All right, what do you think about the sketching? Why don't I give you two of them for you to do on your own, okay? And you try and sketch them out, give me domain and range, and then after you're done, we'll talk about it. So I'll do part A. How about f of x is negative 1/2 x plus 1 minus 2. And B is, I'll do g of x is two minus 4 to the x minus 2. So remember, you start with what is your base toolbox function, and then move it around. I'll give you some time. And get some water. and then the whole thing down 2 from here. So 1, 2, 1, 2, 1, 2. What else comes down to? The horizontal. So 1, 2. So it'll look like this. This is the answer right here. That one's the answer. Does that make sense? I haven't looked, but I think if you do it in any other order, it might get messed up. Well, definitely if you move it down before you reflect it, it's going to be bad. Okay. So then, what's that? What?
Yeah, I messed up the order.
You moved it down first? Yeah. See that negative? That negative is not the base. Remember we said that the base can't be negative? Right? That negative is outside. It's not, if it were in the parentheses, then it would be raised to the power. Then, you know, that's not going to happen in this class. So be aware that that negative is not part of the base. The base of this exponential function is 1/2. The base of this exponential function is what? Just 4. So that's kind of like the same problem as up there. Let me rearrange it. It's like negative, and then it's like 4 to the x minus 2, and then plus 2, if I rearrange things around. I'm not going to do this one right now. Let's just talk about what you would do. You graph 4 to the x first, move it, or reflect. What do we? Right 2, flip it over the x-axis, up 2. Okay. How are we doing on time? 20 minutes? Last concept of the day. And I hate to save this for the end, but this is probably some of the more important things, or one of the more important things we need to discuss. So, yeah. So here's the deal: if solving equations, let's talk about solving equations for a minute. If I give you an example of a linear equation, 3x minus 5 equals 4 times x plus 1 minus 7. That's an example of a linear equation, isn't it? And we call it a linear equation because it has an equal sign. X is in here. X is raised to the first power. And so how would we go about solving that? Move everything over, get all your x's on one side, numbers on the other, and we could do that, right? We're okay with this? I'm not going to work it out. We have a way of doing that. Quadratic equations. You know, same story. 3x squared equals 5x minus 4, whatever. It doesn't matter. If it's a quadratic, we have ways of doing this, right? We usually try and factor usually first. But if we can't factor, we'll break out the quadratic formula if we have to, right? And then there's other things we can do. We can do, I don't know, radical equations. Things like square root of x plus 1 minus x equals 4. And we actually had a process for this. Isolate the radical, square both sides, blah, blah, blah. And you go through, and we have something. We have a process, a way of doing it, right? We also had rational equations. X plus 4 over x minus 3 equals 5. Solve for x. So we would clear fractions and we'd get x, right? Check. We can, theoretically, we've seen all these. We know we have a way of getting what x is. But what about an equation that looks like this, which we call an exponential equation? What's the difference between this and everything that we've done in our lives when it comes to solving equations? What's different here?
Well, the X is there.
We don't know how to do it, but why is it that we don't know how to do it?
Why can't we do it? You
Because we
just-
don't
it's-
know how to.
Why? Because there's a plus 0 out there, and you just move it over.
But what do you do with the?
How do you get x by itself,
Oh.
right? All of these problems, don't we eventually at the end get like x equals 2, x equals whatever, and we just have ways of manipulating things and to finally get x by itself. So how do you get x by itself?
There's like a natural log of 3x minus 1 times 5. Or something like that.
Yes.
That's like
What the hell's a natural log?
the log.
I haven't talked about logs. But you're right, yes. The way to do this is using logarithms, but we have to act like we haven't seen them. Some people have, so yes. We're building to that. Right now, though, if we act like we've never seen logs before, because right now logs should be foreign to everyone, or pretend like they are, we have no way of getting x by itself here. You can't just like, I don't know, bring the x down. There's nothing you can do algebraically. You have no algebraic tools. Over here, like this, I could move the x over. I could square both sides. These were all legitimate algebraic moves, weren't they? Here I could clear fractions, right? All things that we know how to do. What are you going to do on both sides of this to get x down from there? Because see, it's trapped up top. So that's why we have to study this topic. That's why we have to get into this whole thing, is to be able to solve equations like this. And why do you need to solve equations like this? This is the way a lot of finance and banking stuff works. They use exponential equations all the time, and so, or exponential functions, and so we need to be able to handle exponential equations. I'm not going to be able to solve that for you right now, okay? But this is kind of like the open question. Can we do this? Can we do things like this?
Obviously, you brought it up.
Yep. So stay tuned, all right? Stay tuned.
To be continued next week on.
Stay tuned.
Stay tuned.
Right now we don't. But there are some things that we actually can handle if they're written a certain way. Like this. I'll make it real simple for us. I just freaking gave it away. Sorry. Oops. But I think you would have got it anyway. X is 2.
Yep.
We solved that by visual inspection, right? We all know if x is 2, that's true. Here, you can't tell me what x is, right? You can't even tell me what power to raise 5 to get 8, because you can't think of that, can you? But there will be an answer to that. So here, the answer is 2. But let me show you something. I could rewrite this 25 as 5 squared, couldn't I? And then, if this to the x has to be equal to the same thing to the 2, that means these two have to match, don't they? So that tells you that x is 2. Let me give you another example that's like this, but a little bit harder. 4 to the x equals 2. One half, why? Square root of 4 is 2, right? So you can do that one by inspection also. But can you try and do it this way? Try and get both sides of the equation to have the same base. Okay, good. No, I like that. 4, you want to rewrite 4 as what? 2 to the 2. Does everyone agree that that's 4? So 4 to the x. That's the left side. Do you agree? Right side's 2 to the 1? Yeah. Is that all right? Say again?
So 2x equals 1, and then you divide both sides.
Yes. Yes. 2x is going to be 1, but I want to do one more step. Something to a power, you multiply those two powers. So this is 2 to the 2x equals 2 to the 1. And now I hope it's obvious that 2x must equal 1. That means x must be a half. And that's the answer, right? We're getting lucky here because we're able, well, all the problems I've given you so far, you can just look and tell me the answer probably, but the thing that's allowing us to do this mechanically is that we're able to get both sides in terms of the same base. So let me give you another one. You think you're bad? Y'all seem like y'all got this. I'm going to try and challenge you a little bit now. Let's see what happens. Are you shaking? 8 to the 2x equals 4 to the x minus 1. So no one's going to tell me what that answer is just by looking. I don't think.
You're sitting in this class, just be like, oh, that's.
Well, I'm saying like this one, right? Everyone was like 1/2. Yeah, if you could just look at that and say, I'd be like,
I guess you could take the 8 to 2x and divide that all by 2, because if you take 8 divided by 2, it's 4. So
Can you do that? Let's think about that for a second. Can you divide this by 2? That's a great question.
Do 2 to the 3rd power times.
You could do 8 as 2 to the 3rd power, yes, but let me address this other question. Can you divide this by 2?
Not without doing it to the other side.
What's order of operations?
you got to do the other side.
Exponents before division? I can't divide this by 2 because I don't know what this number is. The only way I would know what this number is if I actually knew what x was. And because of that, I'm restricted. I can't divide it by 2. But I'm glad you said that.
I got x equals 1/2.
You got x is a half? Okay. So did you rewrite 8 as 2 to the 3rd?
Yes.
Yes? And then what about the 4? Okay, so 8 and 4, the common base that they share is 2. So we rewrite 8 as 2 to the 3rd, but then all of that to the 2x. We rewrite 4 as 2 squared, but all of that to the x minus 1. We okay with that? Then you multiply powers. 2 to the 3 to the 2x, these two multiply, you get 2 to the 6x. So 2 to the 6x must be equal to the right side, which would be 2 to the what? 2x minus 2. So when you multiply this times this, since this has two terms, it has to distribute through. 2x minus 2. And now that you have the same base, those two must match. Right? Those two have to be equal if you want these two sides of the equation to be equal. So now you can switch this into this and then subtract 2x from both sides. Negative a half. Close. But the kids didn't make it, sorry.
They should have drove faster. What happens if that bases don't match?
We can't do it. And the first problem I gave you where I said stay tuned,
They don't
you
match.
can't do it. So there's got to be a way that we can do it. This is us getting lucky. And there's a set of problems here towards the end of the section for homework that are like this, where you can get the bases to match. So they want you to, practice this.
That's you getting lucky, though.
That's you getting lucky. Yeah.
Have skills.
Yes. Later on, we won't necessarily use this. We would use the skill later. the log stuff. But this is good exercise in exponents. So how about this one? I want to see what you'll do with this one. We'll say this is the last problem of the day. You try it. Quiz, hold on, let me get this hard one. There's one that's never been solved before here. No, I'm kidding.
Not even by you?
I'm kidding. I'm kidding.
Like, not even me.
Nobody has ever done it. How about this? 9 raised to the 2x times 27 to the x cubed. Hold on, that was x squared. I apologize. Equals 3 to the negative 1.
Did you ever see that some professor solve some equation that no one could?
Well, we can't have nice
It happened
Recently?
2 weeks ago maybe?
2 weeks ago?
Maybe 3.
I don't know.
It was recent. I just figured you'd get excited about it.
I didn't hear about that. I know that someone did, there was a professor that did solve a pretty long-standing problem about prime numbers recently. But,
That's some theorem. I don't even know. I'll have to look it up again.
yeah, let me know if you can remember, or tell me about it next class or something. See what you can do with that. Solve for x. If you get it, raise your hand. I'll come by and I'll see. I'll see if it matches what I think you should get. Good, good. All right, rock and roll. You're good to go.
I think I did something.
So,
Can I multiply them?
do you multiply them?
Can I? To get
Do
12x cubed?
Do you? That's my question is, do you? When you put these two together, right? These are both
Oh,
3.
you add them because they're, okay.
There you go. So that should be 4x. There you go. Yep. Then you have a quadratic, right? Let me see the right side, though. I didn't see what you... yes, okay.
Oh wait, since it's exponents and multiplying, oh I see.
That turns to addition.
Yep.
Okay. Same thing. That should be... Yeah, 4x. Yep. Mm-hmm. Yeah, you're good. Keep going. Just equal 0. Just equal 0. You're almost there. This is a plus. That 4x, because when you multiply, when you have the same base, you add exponents.
Okay.
There's only a few minutes left. I think I'll put the work up here below it. Oh, shit. You think you do, or you don't think you do?
I just want to know if I'm on the right track. So, am I on the right track here? Because then you can add these together and then multiply them out, or do I need to multiply them and then add them out?
Is that a 5?
Yeah.
Where'd you get the 5 from?
2 and 3.
No. Get everything in terms of a base 3 first. They all are common base 3. Multiply this. 2 times
Well, that's
2,
4.
4x.
Yeah.
So that one should be 3 to the 4x.
Okay.
Times the next one, which should be 3 to the
Okay,
3x
so
squared.
I have to get rid of these first,
Yes.
And then
Then you can match them up.
So what do I do at this point? I'm assuming assuming these are all base 3.
This is all good, but that should be a plus. I think a lot of people are getting stuck on the same thing. If you got -1 and -1/3, that's great. Let me just show you. This is 3 squared to the 2x times 3 cubed to the x squared equals 3 to the -1. So I would like to try and get everything base 3. Right? Base 3. 3 to something, I multiply those two together. Get 3 to the what? 4x. Times 3 to the 3x squared equals 3 to the -1. Now you cannot match the sides up yet because this is two different things, right? Put these two together. Something to a power times something to a power. If they have the same base and we put them together with multiplication, what do you do to the exponents? You add them. So that should be 4x plus 3x squared equals 3 to the -1. Then you can match the base. You can match the exponents because this is 3 to something. You match this with this. So you write down 4x plus 3x squared equals -1. Now what kind of equation is that? Quadratic. And once you got quadratic, you can do whichever. Quadratic formula, factor, it'll work both ways. You should get two answers, -1 and -1/3. Do you see where the plus comes from though? Okay, that's an important step. Anyone have a question on that? All right.